Hi, today we're going through a PAT paper from 2016, looking at question 8. Okay, so in this question, question 8, we're asked to find x in terms of r, such that the area of this octagon and this circle are equal. Okay, so how can we find the area of this? We obviously have to find the area of this, it's simply pi r squared. So how can we find the area of this octagon? What you notice is that this is in fact a square with triangles, right angled triangles, cut out of the corners. And in fact, we notice all of those triangles have the same area. So we can find the area of one of these triangles. We know the square is going to be x by x, so we know the area of the square. So we can simply subtract 4 times the area of the triangles to get the area of the octagon. But how are we going to find the area? Well, what we're going to do is we're going to define the length of one of these sides to be a. And but we know that the width of this is x. So this implies that the length of this is x. In fact, we'll zoom in. It's going to be x minus a divided by 2. That's because the length is x, and there's two of these on the length, so it's x minus a over 2. And you can check that. So x minus a over 2 plus the other one, x minus a over 2, gives you x minus a plus the a gives us x. So the length is x. And by symmetry, we see clearly that this length is also x minus a over 2. And then we have that this is of length a. And we have a right angle here. Okay, well, then we can see by Pythagoras' theorem, a squared is equal to x minus a over 2 squared plus x minus a over 2 squared. Well, that's equal to x squared minus 2ax plus a squared over 4 plus x squared minus 2ax plus a squared over 4. And therefore, a squared is equal to x squared minus 2ax plus a squared over 2 when we add them together, which implies, well, if we times through by the 2, times through by the 2, subtract the a squared over, we get that in fact a squared plus 2ax minus x squared is equal to 0. Well, we've introduced the variable x. We don't want the variable, we introduced the variable a. So we can't have that in our final answer. So we need to somehow get rid of the a and get a in terms of x. So how are we going to do that? All we're going to do is complete the square. Complete the square. So doing that, we get a plus x all squared. So we do that because we know we're going to get an a squared plus 2ax. We only get a plus x squared coming from here, but we want a minus x squared. So we're going to add on a minus 2x squared, and that's equal to 0. And then, therefore, coming up here, we get a plus x all squared is equal to root 2x. Yeah, sorry, that's x plus 2 if we square root both sides. So x plus 2 all squared is equal to 2x squared. Square rooting gives us root 2x, which implies a is in fact equal to x into root 2 minus 1. Okay, so how does that help us? Well, we know the area of the square is equal to simply x squared. That's the width times the height. And what's the area of one of our triangles? Well, the area of the triangle is equal to, well, we know now that we have now its base width and its height. So it's x minus a over 2 times x minus a over 2 divided by 2. So it's half base times height. So area of triangle is going to be x minus a over 2 all squared times 1/2. Well, that's equal to, well, what's x minus a over 2? So that's x minus x into root 2 minus 1 divided by 2 all squared times 1/2. Well, the divided by 2, so we're writing the 2 down, so it gets a squared times 1/2 gives us 1/8. So that gets us x minus x into root 2 minus 1 divided by 8 with the top all squared. Okay, well now we can bring the x out, so that's x squared over 8 times 1 minus root 2 minus minus 1, or 2 minus root 2 all squared. Well, therefore, the area of our octagon is equal to the area of our square minus 4 times the area of our triangle. And we said that's because we're going to have 1, 2, 3, 4 triangles, and they're all exactly the same. So doing that, that's equal to x squared minus x squared over 2 into 2 minus root 2 squared. And then that's equal to x squared into 1 minus 1 half 2 minus root 2 all squared. Okay, so let's expand this out. Well, that's equal to x squared into 1 minus 1 half times 2 squared is 4, minus 2 root 2, minus 2 root 2, minus 4 root 2, plus root 2 squared, plus 2, which is x squared into 1 minus 1 half times 4 is 2, minus a half times minus 4 root 2 is plus 2 root 2, minus a half times plus 2 is minus 1. So they cancel off, and that comes out to give us 2x squared into 1 plus root 2. Apologies, that's incorrect. It's actually a 1 minus a 1 gives you a 0, and then a minus 2. So that should be a minus 1. Or rewriting it in a nicer form, 2x squared into root 2 minus 1. So sorry, that's just to clarify. The 1 and the 1 cancel, and we have a minus 2. And the 2 comes out to give us a minus 1. Okay, well therefore we simply require the area of the octagon equal to the area of the circle. And therefore pi times r squared is equal to 2x squared into root 2 minus 1. Well, therefore x squared is equal to pi over 2 into root 2 minus 1 times r squared. And therefore we see x is in fact equal to pi over 2 times root 2 minus 1 all square rooted times r. And that is the answer.